consume. We're talking about bees, and we're talking about brews. More specifically, how bees have an effect on some of the drinks you may see, maybe around here, maybe at your liquor store, who knows. As well as some similarities bees actually have with people, which I only just learned doing this. Feel free to sit.
All right, one question. You guys don't need on this chair, do you?
No.
Okay.
So first, I'd be remiss if I didn't talk about the importance of bees in the first place. So of course, bees and other animal pollinators, for example, say butterflies and hummingbirds, play a very important role in our daily diet. Now the figures that have been thrown around over the years are a bit different sometimes, but typically they say about 35% of the daily diet, or 1 every 3 spoonfuls on average, is affected by bees or other pollinators. The USDA actually said over 50% of the world's fats and oils come from animal pollinated plants, and 35% of the world's food is animal pollinated as well. So interestingly enough, there's 3 different kinds of bees. You've got the queen bee, of course. The queen bee ensures the hive runs in a working order because they acknowledge the queen bee. So the queen's primary role is essentially, as the only fertile female in the colony, is to continue to mate and create more worker bees and drones. So the queen bee will mate with multiple drones over the years, or not over the years, but over its lifetime, and produce a pretty adequate amount of bees in return. The drone, I don't have a picture for the drone. The drone is the male bee. It comes from an unfertilized. Yep.
How long do bees live?
It sort of depends on their environment, but I believe I've seen 4 to 6 weeks for certain bees. Typically the worker bees, which I actually talk about in just a second.
Okay.
So the drones of male bees, they are from the unfertilized eggs. So they really have only one purpose, and that is to fertilize the queen bee and give her enough genetic material to make more bees. Aside from that, they're basically worthless. They have no stingers in which to defend the hive as needed, and they have no ways of actually acquiring, say, nectar, pollen, or anything they may need for the colony.
They're concubines.
Pretty much, actually.
That's amazing.
And so actually in the fall, when food supply gets low, drones have been known to be ejected and kicked out of the hive indefinitely, probably for the rest of their lifetime. And then you've got the worker bee. Now the worker bee is sort of the jack of all, or should I say Jill of all trades. The worker bee is always a female, fertilized egg, of course. And they do a variety of different roles throughout their lifetime. So first off, after they're born, they start out cleaning they clean up the brood cells. There we go. Essentially, they clean it all up, and when their biological clock tells them, they move on to their next job. At that point, they become the undertakers. They move diseased and dead brood, any bees that to be potential harms to the colony. After that, they move on to basically become a nurse. So they take care of the other larvae that are still being developed. After that, they are able to actually build inside the hive, whether it's comb and wax and things like that. Then they move on to temperature control, because what can live without a decent regulated climate? Ensure the health of the hive. So bees will essentially flap their wings like hot to keep things dry, keep things cool. After that, they become guard bees. They have stingers, of course, they have to defend the hive eventually. So they guard the hive, watch out for any potential risks, any dangers, any potential just threats in general. And their final role before they pass on for the worker bee is foragers. So for the remainder of their life, they will go back and forth from flower or flowering plant to the hive, collecting nectar and anything else that may be required. Typically, they're known to sort of die before they take their way back to the hive. But if they do, that's what the younger undertaker's role is, to take care of. Overall, they all make sure to work together for the better of the hive and for the betterment of the queen bee. So searching for sustenance, so bees look for nectar and pollen. For a while, I only thought nectar and pollen was a side effect. No, they actually want pollen as well. So both are, of course, found within a flower. Flowers are drawing bees in from the sweet smell of nectar, which can be identified from the smell or the sting. Typically, the bee will use the proboscis to sip away all the nectar they possibly can until they're full, or the flower runs dry. Flower runs dry and they're still not full. They move on to the next flower and continue on and so forth until they're full, and they return to the hive to share their gatherings with the worker bees that are able to actually convert it into honey. The worker bee will actually sip the honey from the nectar from the males of the former. And at this point, they may or may not communicate if they're at a sort of a hot spot of of nectar or pollen. Now, pollen is sort of the only natural source of protein that can be found within a 4A hive. So essentially, when of course the bee goes in, pollen gets collected and sticks to the bee. When it goes to other flowers, it does get deposited a little bit, but typically the ones they bring back are given to the nursing bees, which essentially will develop or will chew it up and develop this raw protein in more concentrated form for the larvae to consume. Because in its raw, pure form, it's not really digestible for the younglings. Communication. So bees do not talk vocally like you and I. If there's hundreds of us in one dark area trying to talk above each other, it'd be a nightmare. So they have two primary forms. So one is for more specialized interactions in close proximity, and the other is for sort of distance communication. And just to let you know, it's not fun. So first off, they use pheromones. So each their untitled bee has their own scent. So the queen bee, the two main ones are egg-laying and the queen mandibular sort of pheromones. The egg-laying is, of course, when the queen lays her eggs, it releases a pheromone as scent. So the bees recognize that egg and know, okay, that's not intrusive, that's not potential invasive, that was snuck into the hive. If there is no egg-laying pheromone on these eggs in the hive, they will actually destroy them by eating them. Then there's the queen mandibular. It ensures the scent itself ensures that the entirety of the hive knows the queen is perfectly fine and perfectly well and is actually still inside the hive. The bees that will attend to the queen will actually go and lick the pheromone off of them, and when they move around the hive, the scent gets passed through, and the bees at some point in time go, okay, the queen's perfectly fine, everything's good, business as usual. It also draws in the drones for potential mating, as well as it prevents other worker bees, as I said, the worker bees being female bees, makes them unable to, or tells them not to produce any queen cells, because if the queen does start to falter in her egg-laying abilities, they'll try to look for another potential queen to take over. The drone, as I said, it's got one role, so its pheromone itself is drawing the queen in. But typically, the drones will attract other drones in one location, conglomeration, and mating takes place right then and there. The worker bee has a few different ones. So you got your trail scent, your trail pheromone. And what that does is basically, while the foragers are out looking for flowers, looking for nectar, if they tap it dry, they leave that scent there so bees know not to bother, not to waste their time trying to find nectar in that flower. It goes all dry, go to the next one. The scent pheromone, there we go, attracts other bees to the hive. So if the queen somehow gets out of the hive, gets lost, a lot of them emit the same scent so the queen knows where to go. If they're swarming and they're currently without a home, and some bees sort of start to set up a hive, they release the scent there, and the bees know to actually go to that location. Now the third one is the alarm. So typically that's more so the guard bee's job. So they got two different kinds of alarms. One is identifying potential threats. Typically just potential threats. So they release it to keep the bees sort of on edge and be prepared for battle if something were to happen. So if you have an animal coming through, or if you have a beekeeper trying to check on their hives. They release a sense that bees are already aware that there's something going on. And if a bee actually stings you, of course they do pass, they do perish afterwards, but the venom sac that releases this particular scent gets ripped. So all of a sudden there's a high concentration of this alarm pheromone. And it sort of sends the bees into a fight or flight response. And they're not very happy about it. But typically that's why bee keepers keep a smoke on them. So that also sort of disables the scent temporarily. It masks the scent long enough for them to keep the bees calm and quiet, so hopefully they can deal with everything before the bees sort of catch wind. And of course, if it's done, if you put smoke all over it, it'll take a little bit longer for the bees to recognize it, give you time to get away and sort of cover up the scent as needed. And so even the brood, even the larvae have their own pheromone scent as well. It's very minuscule by comparison to all of these. Essentially, only the nursing bees will actually notice it because they'll pop in, look at their little cells. If they've got this pheromone going out, they'll know, okay, they'll know the age, and they'll know eventually the sex and gender of the bee. And so that's very important because if it's a drone or a worker bee, you're going to allot food differently. Typically, more food or more protein allotted for the worker bee versus the drone. Now, you can't just leave a scent everywhere to communicate something very far away. So if you find a treasure trove of sorts, for lack of a better word, of nectar or other resources, does anyone have any idea how they actually communicate something that's much farther away? They can't just leave a scent for them to hopefully find. Any idea? They dance. So they got a little bit of wiggle, and it's interesting. They basically just dance. That's how they say, I found something. And sometimes bees will try to mimic it, sort of go like, okay, I think I know what you're talking about. So typically it starts, they find a food source, return to the hive, they do the waggle dance. That's a scientific name for it, actually, the waggle dance. They use the sun's position, so it's very precise. So their movements have to be congruent with the sun. It's all angular, of course. And if it takes a very long time to do this dance, they have to keep that into account and kind of shift and move around accordingly. And how long it takes does show how far away it is. So they use the angle as the general direction, and they'll go, so on here it says about 75 milliseconds means 100 meters away from the hive. Interesting enough. And so the bees will try to mimic the movements and go, okay, I think I know where you're talking about, I think I know where we're going, and they'll start to move on in that direction until they run out of supplies, run out of nectar in that area. Now, typically, they will actually also share the nectar a little bit, or that they gather. So the bees have it going off and go, actually, there's some really good stuff, some really quality nectar. So we're definitely going to listen to you and actually go to where it is. And of course, I mean, this way you mentioned pollination before getting into good stuff. So of course, you have the pollen-bearing flowers, and bees and other animal pollinators, or vectors. So vectors include animal pollinators as well as wind and water. That's one of the primary ways of pollination called cross-pollination, where the plant needs to bring pollen to another flower but has no means of doing it. Others are able to self-pollinate, but in this case, they will utilize, make their pollen grains, and the bees, or honeybees, butterflies, etc., will go and attach the pollen themselves inadvertently, on purpose. Nobody quite knows. When they go over to a different flower that actually needs the pollen to reproduce, say, seeds and fruits. Some will actually be deposited in the stigma of the flower, and some will stay on the bee for the protein consumption when they become the hive. Now, the germination process is not a guarantee. Sometimes it works, and they develop fruits and seeds. Other times, nothing happens. You really just gotta hope. Those flowers are really just on a wing and a prayer, basically. There's a chance, there's not a guarantee. Now for the good stuff. So there's a lot of drinks that you'll see, say around here, for example, that's going to rely on bees in some way, shape, or form. So you've got three that I'm going to mention this slide alone. First, you've got your hard ciders. So traditionally, it's apples. So apples will, most of the time, they do require some degree of pollination from an extra pollen. A few varieties do actually self-pollinate, but traditionally, statistically, they're more likely to find bees or some other kind of pollinator to have an effect on what you put behind ciders. Then you've got your wines. So the pollinators, like these, they're not actually pollinating the grapes that you find in your commercial vineyards. For the sake of time and money, they will put cover crops over around the grapevines. Typically, you've got your oats, you've got your clover and peas. Essentially, the micronutrients they produce go into the soil, keeps things going. So really, if the bees can keep the cover crops going, the cover crops can keep the soil going, the soil can keep the grapes going. And lo and behold, after a long time, you've got one. And the third one I'm going to say is a given mead. It's literally known as honey wine, so unless you've made your own, you kind of need bees to make honey wine. But what about beer? That's the real question we're here for today, aren't we? Is the production of beer affected by the pollination cycle? Well, yes, but actually no. So beer is used by three primary ingredients typically. You've got your grains, you've got barley, which can pollinate, cross-pollinate, but uses wind. Some other ones do. Actually, let me mix that up just now. Let me make sure I'm accurate. Barley self-pollinates. Rye does require cross-pollination, but rye is used to hops. They can easily cross-pollinate using wind as well. In a commercial setting, though, they do actually not want pollination, technically. In a commercial setting, say if you're in Washington State where there's a lot of hops being grown, they actually make sure to only go for female hops. So female hops. They actually make sure to only go for female hops. So female hops are the most cone-bearing. There's a lot of big cones used. So there's a lot more, if you're going to make what you're planning to make with the hops, it's much more economically feasible to focus on the female hops. The males just produce little cones and pollen, that's it. So of course, how do you grow the female hops if you don't have the pollination cycle going in? They use root cuttings of previously grown hops. to, and then planted in the soil, and they essentially cloned a hop more or less for this process. Now the final one is yeast. Now yeast is a tricky one, and I'm going to talk about that in the next slide, but it's basically a microorganism found nearly everywhere depending on the kind you're looking for. Just really varies, and I'll talk about that in a second. So additives, say you've got fruits or spices added to your beer, like say, actually, you've seen the drink menu before walking in here, the confusion says fruit and spices in it. More likely than not, there's probably been some degree of pollination done on the materials used. Yeast for beer. So you've got two very popular ones, ale and lager. Those do not have any particular concentration of bees necessarily, but they're very popular choices. You've got ale and lager. The scientific names I put there to make it sound like I'm very smart, but they look like Harry Potter stuff. So, ale yeast, it ferments at a much warmer temperature than lager. It's also top fermenting, so you add it to your container, and the fermentation cycle starts. It stays at the top of the jar. Lager, on the other hand, sinks to the bottom before it ferments. Ale, in comparison to lager as well, is a much shorter brewing period. Meanwhile, you've got the literal wild card, wild yeast. Now, it's found just about anywhere. There's two different kinds, but typically it's viewed as a brewing contaminant. It's the black sheep of the yeast family. Basically, it would most likely get in when yeast being used for brewing is exposed to air, and so it'll mess up the actual flavor entirely. It'll ruin the balance of the straw. So the two kinds, the one that's really prevalent is Saccharomyces Cerevisiae, by that I mean ale brewer's yeast, mixed with a wild yeast, and that will cause the beer itself to over-attenuate, which means it aggressively ferments and the balance is just gone. The flavor itself gets kind of messed up in the end. The second kind is not that, not that one. And that's one that's truly found nearly everywhere. Typically, when it's added into anything, it gives a very sour taste. So it's really it's not as desired as people would, by comparison to your ale and lager. But some have been used deliberately for sour ales or sour beers, particularly, I think it's called Britannomyces. People just call it Brett. Very simple, very straightforward. And they make a Belgian lambic, which is a very sour tasting brew. Good or bad, it's really up to you. As I said, sour or ruins the flavor. So it depends on the yeast you actually go for and find in the wild. Bumble Beer. So here's the one true example I can say where bees really have an effect on beer. So in 2014, North Carolina State University, they were looking to find new beer brewing microbes for an actual festival that's coming in the following year. So they tested a bunch of different insects, particularly animal pollinators, because wild yeast can be found, say, in fruits, in flowers. So they're going, well, they've been visiting a whole lot of these. There's probably this really unique combination that's made. So maybe we can find something good to provide and show people. So ultimately, they were able to find two different kinds of yeasts, of which they've used before. One was from a bee, and the other was from a wasp. It's interesting. So the yeast itself is very versatile. So the actual flavor does depend on how you brew it. So for example, there's two particular ones actually. You can have a honey flavor coming from it, but you didn't have to add any honey whatsoever. Alternatively, if you brew it a different way entirely, you get a nice sour taste. I kind of forgot to mention this. So, how I mentioned, ale takes less time, lager takes more time. Traditional wild yeast take a long time to ferment. Sometimes months, sometimes a year. It varies. But this particular yeast that they actually extracted from the bee and wasp takes only a couple weeks. And people seem to like it. And now, I put almost no bugs were harmed in making these yeasts. So a lot of people were concerned because, you're finding a bee, you're finding a wasp, and you're making stuff out of what you can find on this insect. So the microbiologist that was actually part of this, I believe her name is Ann Madden. She basically said to make all these bumble beers, we maybe harmed only 2 bugs. Harmed, not killed. Actually, let's see if I'm killed. Never mind. 2 are dead. The good.
They're all dead.
By this point. But basically, Ann Madden did shoot back on this and said, we've only killed 2 making bees. You probably killed more just driving to get a drink in the first place. I got kidding about that. But, so there's also a byproduct of these studies. So they did look into insects all over the place. And they had to find some different houses, especially camel crickets. Invasive, people don't really like them. However, they were found a very particular kind of bacteria on it that actually helps to break down waste. And the other, I've got the quote here because I'm terrible at quoting things. Rob Dunn, the applied ecologist of this particular experiment, said, "Imagine what might be hiding in millions of unknown insects across the globe. Anything's possible. We cannot take too many things into account. It's if we find it, cool. If not, we really can't verify it." So of course, I said yeast can exist everywhere initially, or basically. So various forms of yeast can be found in nature. Can fermentation actually occur naturally? Of course they can. So flowers release very sweet nectar. Typically, the bees and other pollinators are able to take this nectar before anything can happen. But on a particularly rainy, humid type of climate, fermentation can occur with the presence of yeast. Now, can anyone tell me what happens when the bees do consume this fermented nectar? Anyone have any clue? They get buzzed, actually. So, I couldn't just leave that one. So the bees do show signs of intoxication. So these bees have little ability to fly around effectively. Basically, they stumble around. They can't pay attention to things. They can't learn new things. I really don't know how this is verified. But apparently, researchers have said, essentially, they act just like you and me if we've had a little bit too much to drink.
They just did.
They do. They're like, I found something. No, you didn't. So, but the ones that do make it back to the hive are not allowed in. There's a zero tolerance policy. So the guard bees look for any potential irregularities, any potential threats or dangers to the hive. And if they see you strutting around, just a little wobble going on, the bees are going to go, "You're not coming in here. Nothing's happening. We do not want to risk the health of the hive because you just want to have a good time and come back in." So typically it does help reduce the risk of fermenting, getting fermented honey. However, fermentation in the hives still happens. Typically it's when the colony itself is very weakened. As I mentioned, worker bees at some point in their life do have a climate control basically job. If they're unable to completely keep things under control, moisture can get in, it can become humid inside the hive, and the honey or nectar will ferment on its own in there, which can be a very big danger to the hive because, of course, everyone's partying, no one's working. Alternatively, if the honey they make isn't capped right, moisture can be let back in and result in the same deal. So now the next question remains. If bees can become intoxicated like people, can they become dependent on it as well? They can actually. Bees have been shown in studies to actually look for it more often. So in the early 2000s, late 90s, a lot of testing and research was done on bees, for example. They were looking for social insects. Bees were the proper one to go off of. They were using them as an ethanol inebriation model. Very fancy word to say, we see what happens when they drink. And they wanted to, quote, understand addiction on a molecular level. So, for one example, they put bees in tiny little harnesses. I have not been able to find a picture, but I really want to see a bee in a tiny harness. Unfortunately, those results are not there. Just the actual text results. Put them in tiny harnesses and fed them varying amounts of alcohol, typically sucrose with ethanol spiked in. Varying rates, varying concentrations. And they just watch the bees just have a good time after that and not find a way back home. Fast forward to 2018, actually, there's been, or not 2018, this year, in June, last June, there was a published article that said they were able to find that bees suffer from alcohol withdrawal. What they did was they did the same thing. Varying concentrations of sucrose mixed with ethanol. And essentially, the bees that was their only source of any food and nectar for miles, really. So they made it a very controlled environment. And the bees would have these for a while, get very used to having this ethanol-laced sucrose in it. And eventually they took it all away and gave them just the bare bone sucrose, so just regular stuff. Made them go cold turkey. What they found is that the bees will actually go and consume a lot more sucrose than they typically would. And there was a slight increase in mortality, which they considered the bees became desperate. That's definitely a sign of withdrawal. But what they also found is there's very tolerance. So as I said, many bees have their own different roles in the hive. So of course they have their own tolerances. Forager bees, for example, have a much higher tolerance than bees that live their life inside the hive, because they're most likely exposed to fermented nectar or other fermented goods while they're out searching for materials and goods. Meanwhile, if you've got your regular worker bees inside the hive, they are not exposed to these on a daily, if not weekly basis. And hits them a lot harder. It just doesn't end well for anybody, really, in the bee sense. One quote was saying that typically bees could essentially consume the equivalent of 9 glasses of wine for a person in one sitting. And you're like, are you sure these are okay? So on a lighter note, and sort of an ending note really, bees have been used in 2003 as a test subject for disulfiram. Now disulfiram, also known as antabuse, is a alcohol treatment drug. So they said if bees can become intoxicated and become dependent on alcohol as well, let's see if we can use them as a model to make sure, or test and see if it's actually effective. So they used a variety of different tests. They essentially did very scented piles of sucrose. I believe it was a lavender scent, it was an unscented, and with different concentrations on it. So first they had their control groups. They pre-treated these bees with water. They consumed water, and they went out into the wild to look for their sucrose, wild, loosely. And typically they still went towards the ethanol-ridden sucrose 9 times out of 10. When they're fed the disulfiram, while the results did still vary, I mean, this is the wild, of course, typically the bees did avoid the alcohol. So people just did consider that the use of disulfiram, albeit on an insect, was a very good, effective way of making sure there's actually results that come out of this drug. Yeah, so thank you for listening. There's an odd way to end the presentation. I'd also like to thank my main man Barrett. He also worked at TVC with us. He had the notes set up for this before he finished his time here. So I'd be kind of rude if I didn't mention him, of course. I can't take all the credit. And if y'all are curious, that just hurt my brain reading all those sources. If there's any questions, I'll answer them to the best of my ability. But
I just want to say that cedar waxwings also get drunk. Like they eat, so like the service berries, they like turn like a dark purple and they start to ferment. And they like flock towards them and they eat them. John Stoll has told me that he's seen them hanging upside down from the service berry bushes, like in a dazed confusion.
I wouldn't doubt it, because those are likely social insects as well. And if it wasn't for bees, they'd probably be tested as well.
Yes. But I've eaten